let's look at this problem. Find the number of ordered triplets x minus y, y minus z, z minus x, where x, y, z satisfies x into x minus 1 plus 2yz is equal to y into y minus 1 plus 2zx is equal to z into z minus 1 plus 2xy. So let's say all these three are equal, right? So let's say we'll equate them to k. So if I equate each of the equations to k is equal to k, this is equation number 1. So y into y minus 1 plus 2 zx is equal to k, this is second equation. Z into z minus 1 plus 2xy is equal to k, this is third equation. So let's say now I want to solve these. So we'll do 1 minus 2 first. If I do 1 minus 2, I'll get x square minus x minus y square plus y plus 2yz minus 2zx is equal to 0, because k minus k. So if I try to rearrange this, so here I'll have x square minus y square, so x plus y into x minus y. Now minus 1 into x minus y. Now here 2z I can take common, y minus x is equal to 0. So all these terms will have x minus y as factor. So x minus y into x plus y minus 1 minus 2z is equal to 0. So this is first equation, and then 2 minus 3. So if I do 2 minus 3, y square minus z square minus y plus z plus 2zx minus 2xy is equal to 0. So again y minus z will be a factor. So y plus z minus 1 minus 2x is equal to 0. Again 1 minus 3 equal to 1 minus 3 we are doing. So if I do 1 minus 3, x square minus z square minus x plus z plus 2yz minus 2xy is equal to 0. So x minus z into x plus z minus 1 minus 2y is equal to 0. So let's say here we have a into b, a into b, a into b, like that, right? So first what we do is either this is 0 or this is 0. So first we'll assume that if this is 0, x equal to y will get. Here if this is 0, y equal to z will get. If this is 0, x equal to z will get. So if all these are equal, if these are non-zeros, then x minus y is equal to 0, y minus z equal to 0, x minus z equal to 0. So one solution will be 0 comma 0 comma 0. So one possible solution, so case 1. So if these are zeros directly, case 2, none of them are zeros, none of them are zeros. Now these can be 0. So x minus y is not equal to 0, y minus z is not equal to 0, x minus z is not equal to 0. Then what we are left with is x plus y minus 1 minus 2z should be 0, y plus z minus 1 minus 2x equal to 0, and x plus z minus 1 minus 2y is equal to 0. So these are the three equations which we have. So add all these three equations once. If I add this, x is present twice, so 2x, y is also twice, plus 2z minus 3 minus 2x minus 2y minus 3z is equal to 0. So these are present, 2x is there, minus 2x is there, 2y minus 2y, 2z minus 2z. So all will get cancelled, minus 3 equal to 0, which is not possible. So if none of them is 0, will not give any solution. So case 3, 1 is 0. So it means x minus y is equal to 0. 1 is clearly 0. See, if 2 are 0, it indicates the third one is 0 clearly, because if 2 are 0, x minus y equal to 0, y minus z equal to 0, it means x equal to y, y equal to z. It means x equal to z in turn. So two of them will not be 0, only one can be 0. If one is 0, we'll have x is equal to y. If x equal to y is there, so substitute in the other equations. We are solving from first equation, right? So let's say I will keep in second equation. So there z is there. So instead of z, and wherever x is there, I will replace it with y. So y minus z should not be equal to 0. So then y plus z minus 1 minus 2x should be 0 clearly. So y plus z minus 1 minus 2y is equal to 0. So we'll have z minus y minus 1 is equal to 0. So z minus y is equal to 1 will have. Y minus z is equal to minus 1. Okay. So the ordered triplet is x minus y, y minus z, z minus x. So here we are saying x equal to y, no? So x minus y, so y minus z, z minus y. So here it will be x minus y is 0, y minus z is minus 1, z minus y is 1. So like this we can take the other things also. We can consider y minus z is equal to 0. So y equal to z. So for y equal to z, so x minus y, y minus z, z minus x, right again. So we'll get, so y minus z, so it will be minus 1, 0, 1 will get. Again we'll make x minus z is equal to 0. So it means x equal to z. So it is x minus y, y minus z, z minus x. So this is, so we are saying z is equal to x, right? So x minus y, y minus x, 0. So this is 1 minus 1, 0 is the solution. So we have three solutions here. So for these three cases we'll have three solutions when only one of them is 0. So in the product only one we are taking 0, and if all the terms are zeros we'll have one more solution, 0 0. If all three are non-zero we don't get a solution. If two are 0 it directly indicates the third one is 0. So the number of solutions here are, so number of possible solutions are 4. That is 1 0 solution, 0 0 0, other one is 0 minus 1 1 and minus 1 0 1 and 1 minus 1 0. So we'll have these three 4 possible solutions.